2.3.1 LDAP Distinguished Name Syntax DNS. Entries in the lightweight directory access protocol directory are identified by their names. The characteristics of these names are they have two forms, a string representation and a URL. They have uniform syntax, namespace boundaries are not apparent in them. A component of a name is called the relative distinguished name, RDN, and RDN represents the point within the namespace hierarchy. RDNs are separated by and concatenated using a comma. Each RDN is typed. RDNs have the form type is value for single-valued RDNs. The plus sign, plus, is used to form multi-value RDNs. Type is value plus type is value. The type is case insensitive, and the value is defined to have a particular syntax. The order of RDNs in LDAP name is the most specific RDN, first followed by the less specific RDNs moving up to a DIT hierarchy. A concatenated series of RDNs equates to this distinguished name. The DN is used to represent an object and the path to the object in the hierarchical namespace. The URL format for LDAP has been defined that includes a DN as a component of the URL. These forms are explained in sections that follow. Every entry in the directory has a DN. The DN is the name that uniquely identifies an entry in the directory. The DN is made of attributes and its value pairs, separated by commas. For example, any of the attributes defined in the directory schema may be used to make up DNN. The order of the component attribute value pairs is important. DNN contains one component for each level of the directory hierarchy from the root down to the level where the entry resides. LDAP DNs begin with the most specific attribute, usually some sort of name, and continue with progressively broader attributes, often ending with the country attribute. The first component of the DN is referred to as the relative distinguished name, RDN. It identifies an entry distinctly from any other entries that have the same parent. In the examples above, the RDN CN Roger Smith separates the first entry from the second entry, with RDN CN Sandy Brown. These two example DNs are otherwise equivalent. The attribute value pair making up the RDN for an entry must also be present in the entry. This is not true of the other components of the DN. The distinguished name DN syntax supported by the service based on an RFC 2253. The backwards no form BNF syntax is shown in example 2.7, DN syntax. String form 2.3.2. The exact syntax for name is defined in RFC 2253. Rather than duplicating the RFC text, the following are examples of valid distinguished names written in string form. This is a name containing three relative distinguished names, RDNs. OU is depth UVZS CS plus CN is Leslie Smith. OU is Austin. O is IBM. It's a name containing three RDNs in which the first RDN is multivalued. CN is L, eagle is O. OSU, grab it and run as C is GB. This example shows the method of quoting a comma, using a backslash as the escape character in an organization name. CN before OD, after O test C, GB. This is an example name in which the value contains the carrier's return character O0 or DH. URL form. Functional model. The LDAP Lightweight Directory Access Protocol functional model is comprised of three categories of operations that can be performed against the LDAP version 3 directory service. Authentication, bind, unbind, and abandon. Operations used to connect and disconnect to and from an LDAP server. Establish access rights and protect information. Query, search for and compare entries for entries meeting user specified criteria. Update, add an entry, delete an entry, modify an entry, and modify the distinguished name, modify RDN or relative distinguished name of an entry. 2.4.1 Query. The most common operation is search. The search operation is very flexible and has some of the most complex options. The search operation allows the client to request that an LDAP server search through some portion of the DIT for information meeting user specified criteria in order to read and list the results. There are no separate operations for read and list. They are incorporated in the search function. The search can be very general or very specific. The search operation allows one to specify a starting point within the DIT. How do you put the DIT to search? What attributes an entry must have to be considered a match, and what attributes to return for matched entries. Some example searches expressed informally in English are: find the postal address for C and John Smith, O is IBM, C is DE, find all the entries that are children of the entry OU, ITOS, O is IBM, C is US, find the email address and phone number of anyone in the IBM whose last name contains the character Miller. Now, and who also has a fax number. To perform a search, the following parameters must be specified. Base, a DN that defines the starting point. Attributes to return. Specifies which attributes to retrieve from entries that match the search criteria. Since an entry may have many attributes, this allows the user to only see the attributes they are interested in. Normally the user is interested in the value of the attributes. However, it is possible to return only the attribute types and not their values. This could be useful if a larger value, like a JPEG photograph, is needed for every entry you returned from a search, but some of the photographs will be retrieved later as needed. Alias dereferencing specifies if aliases are dereferenced, that is, if alias entry itself or the entry points to is used. Aliases can be dereferenced or not when locating the base object or when searching under the base object. If aliases are dereferenced, then they are alternate names for objects of interest in the directory. Not dereferencing. Aliases allows the alias entries themselves to be examined. Limits. Searches can be very general, examining large subtrees and causing many entries to be returned. The user can specify time and size limits to prevent wayward searching from consuming too many resources. The size limit restricts the number of entries returned from the search. The time limit limits the total time of the client search. Searchers are free to impose tickets, stricter limits than requested by the client. 2.4.2 Referrals and continuation of references. If the server does not contain the base object, it will return the referral to a server that does, if possible. Once the object is found at a single level and whole subtree searches may encounter other referrals, these referrals are returned in the search result along with other matching entries. These referrals are called continuation references because they indicate where a search could be continued. For example, when searching a subtree of anybody named Smith, a continuation reference made to another server might be returned, possibly along with several other matching entries. It is not guaranteed that an entry for somebody named Smith actually exists at that server. Only that a continuation reference points to a subtree that could contain an entry. It is up to the client to follow continuation references if desired. Since only LDAP version 3 specifies referrals, continuation references are not supported in earlier versions. 2.4.3 Search filter syntax. The search filter defines criteria that an entry must match to be returned from a search. The basic component of a search filter is an attribute value assertion of the form. Attribute operator value. For example, to search for a person named John Smith, the search filter would be CN is John Smith. In this case, CN is the attribute, the equal sign is the operator, and John Smith is the value. This search filter matches entries with the common name. Table 2-5 shows the search filter options. We're going to read something else. We reached page 74 out of 500 pages. Well, ain't that one hell of a month. Now we're going to look for another book. See what books go to documents. Books. Can you find books? Kill by kind. Axel blah blah blah. You know what? Why not search? Just search. Search PDF. PDF, here we go. PDF books. Whoa, we got a lot of books in here. A lot of books. Tutorial practice, parallel worlds. Michio Kaku, Math Illuminated, La Linguistica. Light Measure, Linguistics. Dialectical Deutsch. This is understanding space-time. Capture the con, beyond the question. CFRL. Understanding space-time. Let's see what that holds in. That's that stupid book. Read the contents with me and see how stupid this book is. List of figures, preface, introduction, absolute motion, and the emergence of classical mechanics. Newton and the history of the philosophy of science, the revisionist view, the scientific and philosophical context of Newton's theory, the definition of absolute time, absolute space, and motion, Newton's di gravitazione Aiki Pondio Fluidorum, the Newtonian program to exhibit the system of the world, Newton's accomplishment. Empiricism and parallelism, from Kant to Poincaré, a new approach to metaphysics of nature. Kant's turn from Leibniz to Newton, Kant-Leibniz and the conceptual foundations of science. Kant on absolute space, Helmholtz and the empiricist critic of Kant, the conventionalist critic of Helmholtz empiricism, the limits of Poincaré conventionalism, the 19th century achievement, the origins and scientific significance of relative theory, the philosophical background to special relativity, cultural analysis of simultaneity, from special relativity to the postulate of the absolute world.